Hi there. My name is Arun Rajashekharan. I'm here to give you a talk on enterprise collaboration and how it has been impacted in the recent days and what all could be done to take it further and improve the collaboration experience. Brief introduction. I work for a company called Poly. I'm part of the office of the CTO, primarily focusing on wearables and sensors. My background is in embedded systems as such, embedded firmware, software, signal processing, and more recently, as many in my field, have been strongly fascinated by and looking into how artificial intelligence as a subject within which machine learning capabilities can be utilized. That's my background. So let's get on with the agenda. So I'm going to be spending at least the initial few minutes, this being an IoT Online Conference, giving a pretty rapid-fire background of how things have been evolving around us, how the T's have been transitioning themselves into IoTs, and then I'll talk about, very quickly jump on to collaboration, which is going through a similar dramatic transformation. Talk about core to the edge as it applies to collaboration, and why I think personalization, that's a keyword which I'm going to be converging on and trying to justify why that is what needs to happen for collaboration, for digital collaboration to really succeed in the future. So that's the agenda. So T to IoT, things to Internet of Things. It's been around for a while. It has gone through its own hype cycle. The initial stages, it was not a dramatic transformation. Looking back, right? It was, it was just combining capabilities that already existed. What the pandemic, the COVID situation, that I can safely say all of us have been impacted in one way or the other, and continue to getting impacted all over the world. It has literally accelerated this transformation in many ways, and so many other transformations, as you would see even through my presentation. And the space, even if it changes as things improve because of the pandemic and related effects, this transformation, whole bunch of it is here to stay. Maybe it'll be a little slower, but this acceleration and adaptation of this transformation is for real. So very, very fast, the light bulbs becoming smart light bulbs used to be things that only the elite or the very, very few were even thinking about. It is becoming a real commonplace functionality, and so would some of the examples I'm going to be citing in the next few slides. Your smoke detector, carbon monoxide detector, without a question. There are a lot more practical ways in which there's advancements of technology converting what used to be simple things doing a specific job into a thing that still does that same job, maybe not any differently, but bringing a whole bunch of other capabilities. I don't even have to list what those additional capabilities are. A thermostat, becoming a smart thermostat, your basic wristwatch, giving you the time and helping you do tons of other stuff. The tons of other stuff, each one might have their opinion as to what it is mostly needed for, whether it is the fitness aspect of it, getting notifications or whatever it might be. But this is becoming almost mainstream, I would say. And this is a product that the company I work for built several years back, a simple Bluetooth headphone, which in many ways is giving room to what's called true wireless stereos. I don't need to explain what this product and which company makes this. And these are a lot more capable, the modern headsets like this. It's not just a simple, piece of plastic that has speaker and microphones and rendering audio and picking up audio in an efficient manner. It does a bunch more. It is bound to do way more, because it's a prime real estate in your human body. These devices occupy. What used to be things, the early days of mobile phone, have given way to dramatically capable supercomputers, without any question. So those are also, in my view, Internet of Things, even though the early versions were also, in some ways primitive Internet of Things. An automobile with an IC engine, internal combustion engine, it's not going to go away, but it's getting aggressively transformed into something that has way more smarts and connected, and hence becoming an Internet of Things. So what is, how can you boil this down into, a simple way? What really transforms a T into an IoT, and a modern IoT at that? Its ability to sense, that's increasing dramatically, from sensing simple things, what used to be the case a few years back, to sensing multiple things. Ability to compute then and there, right? And even though it might have connectivity, the ability to compute the data that it is receiving from all possible sensors. We'll talk a little more about this key topic, compute and connected. In many ways, pervasive connectivity is becoming more real than what it used to be. But then a lot of the IoT world probably couldn't afford to have the ultimate forms of connectivity, which is mobile, cellular, whatever you call it. But these are the three key pillars of those three really make a thing into an IoT. That could be a bunch of other things too, but in essence, it boils down to these three capabilities. So let's look at maybe graphically. As you would probably realize, most of my presentations are going to be full of pictures and block diagrammic views and very little text. So early days of IoT, up in the cloud, that's where the connectivity was needed. Either these IoT devices, they were connecting using some wireless technique amongst themselves, but ultimately the aggregated data was sent to the cloud to serve a bigger purpose. So if you remember the three icons I used in my earlier slide, there was connectivity, there was some sort of compute, and there was some simple sensing. And this is how the early days of IoT was defined. And it was fine, because the cloud was almighty and most of the data went to the top. All data digestion, analysis, and even insights were available in the cloud, which the cloud has, without a question, its strengths. Infinite storage, infinite compute capability. So there's nothing that the cloud couldn't do, and that's how the model originated. And it started evolving pretty fast, even before COVID. So if you noticed, I made a sad, the endpoint horizon kind of look a little bit like a smiley face. But this is because the endpoint world started evolving. More type of sensors, sensing capabilities started showing up. More different type of connectivity options started coming up. The compute started becoming more affordable right at the edge, right? Whether it is the power efficiency, the cost efficiency, or whatnot. These changes have been happening for a couple of years, even more than a couple of years, I would say, for the last 4 to 5 years, to make the IoT world more efficient at the edge, and a similar evolution has been happening at the cloud too, without any question. The cloud capabilities in terms of not just aggregating data and crunching data in traditional ways, but really accelerating the machine learning concepts of building phenomenally complex models efficiently. We'll talk a little bit about machine learning down the road. There can be very few presentations in technology without touching on neural networks or machine learning. But this is how IoT as a world was evolving. And the key was, as the evolution happened both at the cloud and at the edge, at the endpoint, at the edge, as I've shown in the chart, it became a little more bifurcated. Things were not just going up. The data that got generated at the edge. There were few more things the edge started doing to make this entire end-to-end system be more efficient. Whether it's a tiny earbud, if you noticed in the one end of your screen, to all the way to an autonomous vehicle. Trademarks are owned by whomever builds these products. And fast forward to 2020, and in my view, this is what happened. The smiley fix, becomes even more happier. That is to denote that the type of compute really have started evolving. And compute, when I say compute, a lot of it is around the silicon and the software that goes with the silicon. If you have been paying attention to where the venture capitalist money has been flowing in the silicon space, it's definitely happening for both ends. But the innovation in the cloud space is centered around very, very few. Probably I can count with both my hands, maybe even one hand, as to who are the key players in the cloud and who supply ammunition to them. But that's not my core expertise. You'll see that I always pivot towards the endpoint or the edge. So there's been so much happening in this compute space. Effectively, it is transforming or bringing capabilities that only the cloud was allowed to have, or cloud, probably allowed is a strong word, cloud compute, certain capabilities, like, for example, inferencing within the machine learning world, was also happening in the cloud. So that's why the previous big picture architecture made every sense. So the edge was designed to keep it designed to be simple, because that's all you could do. There were the constraints didn't allow the edge to be any smarter. So edge sent everything possible to the cloud. So all sorts of training and inferencing in terms of this machine learning model was also happening in the cloud. But at the minimum, what is beginning to happen is efficient inferencing right at the edge is happening, thanks to a huge part to innovations in silicon architecture and the software that goes with it. Tiny ML is one terminology is pretty popular. So in addition to the compute, sensor world was evolving too. And it was sensors were getting smaller, MEMS capabilities were becoming even more affordable. Think of radar like sensors getting really miniaturized and being available for possible design into headset like products, portable electronics. So now imagine the use cases and end user benefits that could arise because of such capabilities. So how could it look like 2020? We are almost there. This is December now and beyond. So a lot of this is bound to accelerate, which is the miniaturization of the sensors, integration of multiple sensors, bringing compute right next to the sensors, which is what and I try to show in the bottom of the screen, because certain type of integrations is pretty vital, so that there is no additional complexities that arise with the system design, as you all know, because data transport in any architecture, it could be a big bottleneck. Not just sensing the data, not just crunching that data, how you move from one place to the other. So if there are opportunities to make them be co-located, the sensing and the compute, it brings a lot of efficiency into the system, reduces latency, safety or privacy of the data. So that's potentially how it's expected to evolve, with 5G for opening up the big bottlenecks to the cloud, to and from the cloud, and technologies like BLE going through some rapid advancements to make these endpoint devices efficiently communicate without burning too much power, right? And again, compute and sensor innovations are so impressive. They're going to be transforming this world of tiny ML or edge compute in a dramatic way. So those the three big contributors to transforming anything to an Internet of Things is something I talked about. That's what is shown here. So in terms of animation, I'm trying to show how bringing compute closer towards the sensors and right at the endpoint or the edge is going to be while there are compute revolutions by themselves. One last point I would say, to close out this T to IoT transformation before jumping into the collaboration topic is compute. The simple way to explain that, which many experts in the field have presented on this, and something that sticks in my mind is how the instruction set architecture, the ISA world that pretty much all of us have been living in and continue to live in, is getting supplemented by this DSA, domain-specific architecture, which is today is claimed to be the most efficient way of doing any machine learning functionality, or for that matter, any neural network type of compute. So this ISA and DSA capabilities coexisting, is what is probably one of some of the biggest innovations that's been happening in the compute world, and that allowing more efficient processing of sensor data, or sensor fusion, as one would call it, is to a huge extent going to be behind how this entire transformation is going to be benefiting the end users. So that's a quick background. So let's talk about collaboration. How the last 12 months effectively, has really changed big time, right? And the next couple of slides, I'll be talking about how it used to be. There were plenty of ways in which collaboration was happening, and then it all became digital. So let's see how that can be explained. So there was this who, where, what, and then how. So the who part, right? All of us, or people like us, either we had one-on-one collaboration possibilities, or one-to-many, or many-to-many. And where did all these collaboration sessions happen? In our offices, in tiny offices, huge offices, campus settings, enterprise campus settings. Some did work from home. It's not like work from home happened only recently. And a whole slew of from simple whiteboards all the way to awesome collaboration tools were used for assisting with this collaboration. And this collaboration was happening in multiple different ways, either face-to-face, which is actually used to be more, one of my favorite way of collaborating with people. It just brings out so many nuances. Nothing can, in my view, replace true face-to-face interaction. But that's not, in a globally connected world, you cannot have face-to-face interaction with even all your colleagues. A lot of organizations are very geographically distributed. So there were on-premise and cloud-based collaboration tools. They really make collaboration that much more convenient. To bring people all over the world together, right? So that's how it was. And then COVID strikes, right? Everything went upside down. And what did it do? It pretty much brought collaboration. What I have shown here is so many of the traditional ways of doing collaboration up until December 2019, or even as recently as Jan 2020 or February, started becoming not practical for various reasons. Key one being a health reason. So but it still happened. We had been living through this last several months collaborating. The jury is still out whether is it exactly the same as the productivity and whatever metric one can come up with. Is it still exactly the same as what it used to be pre-COVID? So I have my opinion on what that could be in the next few slides. But the simple way to see this is, everybody got confined to what was a setting away from work. Maybe some are still going to work, but they are by themselves. That is the key. So how this transforms is transformed from pre-COVID to during COVID is each one was almost always by themselves, and the other person was somebody on yet another screen. Very rarely it was somebody sitting opposite to them. Very small percentage. Maybe there were plexiglasses and all sorts of separations between the two. But to a significant extent, these are all happening electronically. Digital collaboration started becoming the only practical way to collaborate, even in situations where there were, what I've shown at the left over there. Many people collaborating. Each one of those icons that I'm using to show a person was sitting by themselves or standing by themselves or maybe even moving, but they were by themselves, and their images were aggregated thanks to the modern collaboration tools. So the world started becoming simpler in some ways in terms of collaboration. There was pretty much one person on any given end, and they were working from what was defined as work from home scenario, but it's more work from anywhere scenario. Not everybody had a awesome study or a den or a private office, so they made the setting they had, figured out which corner of which property or which building they can work from in terms of collaboration, and used whatever personal tool, collaboration tool that they think is optimal. It could be a mobile phone, laptop. In some cases, products like what the company I work for, they build to make collaboration that much more efficient. Things like video conferencing tools and audio headsets, professional audio headsets. But all this was definitely happening through the cloud, right? So the person was by himself or herself, and it was a SaaS and a software as a service system. It was getting utilized. Every sort of profession, not just engineers or folks who deal with IoT or cloud compute. It is any profession you could think of was to a huge extent utilizing this digital collaboration technique, and every setting was unique. If it was somebody working from home, pets started becoming a commonplace thing. It started showing up in collaboration situation, but that generates the concept I'm trying to establish here is each individual setting is so unique, right? The profession they are in, the location they are in, the type of ambient noise conditions they are in, lighting conditions they are in. Their setting is not, no two people have the same, similar, anything, what's shown at the bottom. The physical location, what's called home, or a portion of the home where they're collaborating from, or the device that they're using. It could be any sort of a laptop or a tablet or a mobile phone, whatever memory footprint. So there were, each one's system, collaboration system, was as unique as the person. So what used to work in an enterprise setting was generalization. Devices and everything. The IT teams would go for such and such laptop, such and such mobile phone, such and such headset or a video conferencing system. Has it gone through these certifications? Then it should be good for everybody. that was the case, that continues to be the case. And what I am arguing here is that is needed still. Maybe it has to be adapted a little differently for the modern world, for the modern digital collaboration world, and it should start thinking about personalization. We'll get back to personalization in a bit. So let's talk about this collaboration universe, the same thing I talked about, cloud to the edge, as it looks for collaboration, with regards to collaboration, digital collaboration. So cloud core, terminology has always existed, but what is defined as edge has been changing constantly, right? I think even in the last 2 to 3 years, the true edge, as I've tried to show in this slide, or the real endpoint of what one claims to be the edge is, it's actually the minute of elements that are in the endpoint devices. So if you were to look from top down, so what I'm trying to show is how this entire ecosystem looks like from top to the bottom. The second red block I've shown here is one could consider the edge of the network, which is directly connected to the cloud subsystem. To a network edge is where most typically endpoint devices are connected, whether it's a laptop or a mobile device or even an EV. But each of those endpoint devices have so many different sensors, display, and camera, and capabilities. Those are gaining smarts, as I had mentioned in my earlier part of the IoT description. So the capabilities are going as low and as close to the sensing aspect of this cloud to edge subsystem, which has not been fully utilized in many ways, and that's behind what I'm trying to get at, how this edge compute revolution is going to impact, how it can actually impact the concept of personalization. So both these are, I think that's a perfect storm brewing in terms of changing the way many industries, not just collaboration, how they're going to benefit from all that's happening, both at the cloud and at the edge. So here is how the system can be mapped to a collaboration world. SaaS providers, and I just showed examples of few, and down at the other end are these devices. I do show an EV, partly jokingly but partly seriously, as autonomous driving capabilities become real. That's nothing that's preventing anybody from taking part in a video conference system. Forget just being on your mobile over audio. It's quite within the grasp of what is bound to happen. Maybe some are already doing it because their car is taking care of the driving, so they can be talking to their or at the minimum the passengers already are or possibly could, and it's just bound to change rapidly over the next several years as autonomous driving starts becoming better and better, right? So I'm not asking any of you to have a video conference while driving, but it's just a possibility. But what is key is what's happening underneath these devices, right? The cameras, the microphones, the 3, 6, 9 axis sensors, various type of temperature, pressure, radar, like sensors, and the silicon capability that is that's getting revolutionized is what we talked about in terms of IoT revolution. The same thing can immensely benefit collaboration. So the same, the cloud to edge system, this actually shows the strengths of both the cloud and the edge. The edge, it's meant to do certain things and certain things more efficiently. It really is not going to replace everything that is in this ecosystem. So if you go way up into the cloud, the visibility of the number of network edges, and each network edge in turn having visibility and access to many more endpoint devices. So all these are nested loops, if you can use that terminology. So so all these are nested capabilities. So the almighty cloud has the broadest visibility, and that's where its biggest strength is. The things that cloud should be doing is functionalities that need visibility across all devices. That no single endpoint can do it as efficiently as cloud. And when you reverse that concept, the cloud shouldn't be, if the architecture allows, and again, there is no simple magical answer that can be applied for every scenario, saying all these belong in the cloud and all these belong in the endpoint. This is a dynamic equation that has to be answered based on the constraints or the objectives that each system, end-to-end system, has. But I think that is with capabilities, some of them things that only a cloud used to have, now being available at the endpoint, gives so many degrees of freedom to make the system that much more efficient. So some of the advantages of an edge compute has been apparent for quite some time, but they're becoming more and more obvious. Lower power consumption, because you're not spending all the time packaging the data and figuring out how to send it to the next level of intelligence, if you can think about it that way, because communication, turning on a radio or whatever medium data needs to be sent across, it's not cheap in terms of power consumption. So if you can crunch the data then and there, you don't need too much bandwidth. Because of these two reasons, the cost starts coming down. What starts going up? The efficiency with which the devices can react. Since you're not sending all the data and waiting for the almighty cloud to send you back the decision, the latency with which decisions get made is smaller. Possibly more accurate, because there is data could get corrupted as you transport. In the older architectures where all the data had to go to the cloud, you're consuming it then and there, and data chances of it getting lost or corrupted is low. And so is privacy, because you're not sending raw audio information or video information. So you're processing and eliminating that data then and there. So it's going to be in my view, like a pendulum. While real early generations, the core or the cloud is all that had capabilities, and now maybe it'll push the world will push it to another extreme in saying that cloud shouldn't be doing too many things and we'll do everything edge. I think that's also impractical. The reality is going to be a strong contribution by both is what's going to make a system that much more efficient. So generalization, it's a point I made earlier. It has helped collaboration in some ways. It'll continue to be needed, but I think personalization, because there's only one person who is using generalized devices and software and application that was built for some other setting, generalized meeting rooms and conference rooms and noise types and lighting conditions and whatnot, which doesn't exist today in majority of the settings, right? So that's what I mean by generalization versus personalization. So how can this personalization really happen? So why should it actually happen? Because collaboration today, as much as we just went with what we have, it's not going to be sufficient. It's in my view, again, it's not the same as the value of the collaboration. What collaboration brought out pre-COVID was delivering. So we're just living with the tools that are given to us. But unless collaboration starts feeling more natural, more intuitive. Ability to share content easily, ability to interact and reach out to different people in a more efficient manner, and make technology disappear. Right? I mean, one shouldn't have to worry about where is my video camera? Is it having the right view? Am I looking okay? Am I sounding okay? Which speaker, which microphone? Because there are so many, again, possible configurations and setup changes that each one could have. So the engagement is definitely, in my view, not the same as what it used to be, and henceforth, productivity. That is a huge aspect, right? End result is also not going to. It's not the same as what it used to be. So personalization can help bridge that gap. So how can we get this personalization? So this digital collaboration, for it to be effective, the SaaS players, as well as the end device manufacturers, right? Whatever you are using, whatever I am using, they have to figure out ways to personalize it. And I'm going to give you some examples. What they can use is some of these modern, AI, machine learning capabilities in silicon and software, both at the core and at the edge, to learn certain things about the person to help with personalization. It's almost like your setup around you knows that it is you and the factors that you normally are exposed to, and adapts itself slowly but steadily to making you have the best collaboration experience possible. So for many of this, the players in this field of collaboration, either it's SaaS vendors or device manufacturers or whatnot, they have to constantly collaborate amongst themselves too. So you cannot expect the end user to untangle the mess as to, am I on a Zoom call versus a Teams call versus WebEx call, whatnot, and how am I going to, do I have to change any setting for every call? So that has to start becoming a lot more simpler, more easier, and above all, it should, things that happen with the tools that we get should make us feel like this is something that is very close to the collaboration experience that we had before, for productivity to be as close as possible to what we had early on. So here are, in terms of collaboration, think of even this scenario. I'm here, using my webcam, my microphone. This specific one is a recording, but if we had a live webinar, it is streaming to each one of the participants, right? And that's the cloud magic. Without SaaS capability, such a thing probably would not be feasible. And at the same time, if it was not a webinar, but instead a conference call, all of us are collaborating, same thing has to get back to me, whether, let's say, there's 5 or 50 or 100 users, there is massive, this transmit and receive, as I kind of point out here, data processing that needs to be happening. For this specific call, I don't have a background, that's getting blurred or some other fancy background, but those kind of compute is happening in the cloud. It's not cheap, it's not easy, but those are interesting capabilities, which I think have a long way to go, in terms of digital collaboration. So if you were to double click into that scenario, one person's transmit is other person's receive, whether you're talking about video or audio. And what I've figuratively shown in the middle is there is no line of sight actually with all this communication. It's not a point-to-point communication. If any of you remember old AOL days or bulletin board days where you dial up, fire up your modem and connect with some other person, and that's a point-to-point communication. So this SaaS world, brave new SaaS world, there is no line of sight. It's not connecting point to point. Instead, here I showed it. I'm showing it to show how one person transmit becomes other person's receive, but the scalability comes to the system because of cloud compute capability. So it's not, that could be not just A and B in our modern collaboration system, as all of you know. So one person's transmit becomes every other person's receive in all possible directions. So this minimum viable product as an acronym. So I'm going to wrap up this personalization, what all are possible, into three broad buckets. I'm not going to list every sub detail within this MVP, three key MVP line items, but I kind of group them into three buckets. One is the user experience. Other is the video, the blue line that shows what is captured right now. There's a webcam that's capturing what I am, what the webcam is picking up as an image, and rendered to everybody on the other side. And the same thing with audio. There's a microphone that picks up my speech and then plays it in the speaker on all the folks who want to listen. So those three, is what I'm listing as some of the key parameters, right, which are ripe for personalization, personal user experience, personalization of a video experience, both transmit and receive, personalization of an audio experience, both transmit and receive, in addition to just having all standard capabilities that everybody gets. So the room for innovation is huge, primarily because of all the tools that are becoming available in an affordable manner in terms of silicon and software at the endpoint devices and at the cloud. So those three key topics is huge. Again, it's a wrap. Just let me mention this again. Again, I probably should have used some politician's quote here. Never let a crisis go wasted, or something along those lines. But there are so many challenges that we have today. Right? It's digital collaboration is not the same as this analog or hybrid collaboration that used to exist. But digital collaboration is here to stay. Even if the pandemic we are in the middle of just starts fading away, digital collaboration is here to stay, and it could even actually improve the quality of life, the quality with which we collaborate with others better. So personalization, in my view, is one of the possibilities. It's collaboration is evolving very fast. That's what we are doing today is not exactly what we did pre-COVID. The individual is in the middle of it all, and that individual and the ambient settings and conditions around that individual is so unique, as unique as the individual. And we have to figure out ways to emulate the collaboration that's happening digitally to be something that is as close as possible to face-to-face interaction. The AMAP is supposed to represent as much as possible. So personalization is key, and advancements in edge compute is probably what's going to make this happen. Thank you for your time.